The sky is one of the most beautiful natural wonders we see every day, yet many people never stop to think about why it is blue or why it turns red, orange, and pink during sunrise and sunset. The explanation is not magic, it is science, and understanding it helps us appreciate the world around us even more. To begin, sunlight is not just white. What looks like white light is actually a combination of many colors, like the colors of a rainbow: violet, indigo, blue, green, yellow, orange, and red. Each color has a different wavelength. Blue light has a shorter wavelength, while red light has a longer wavelength. When sunlight enters Earth's atmosphere, it collides with tiny particles of air such as oxygen and nitrogen molecules. These particles scatter the light in all directions, but they do not scatter all colors equally. Shorter wavelengths like blue and violet get scattered much more than longer wavelengths like red and yellow. This scattering process is called Rayleigh scattering. Even though violet light scatters more strongly than blue light, we mostly see blue because our eyes are more sensitive to blue and because some violet is absorbed by the upper atmosphere. So, during the daytime, blue light spreads across the sky in all directions, and when we look up, we see a beautiful blue sky everywhere. Now imagine sunset or sunrise. During these times, the sun is very close to the horizon and sunlight has to pass through a much thicker layer of atmosphere before reaching our eyes. Because the distance is longer, most of the blue and violet light gets scattered away completely and does not reach us. Only longer wavelength colors, such as red, orange, and yellow, survive the journey and reach our eyes. That is why the sky near the horizon glows with brilliant shades of red, orange, pink, and gold. The dust, smoke, and moisture in the atmosphere can make sunsets appear even more dramatic by enhancing the scattering effect. You may notice that on very clear days the sky looks bright blue, while on cloudy or polluted days it looks pale or even gray. This is because particles like dust and water droplets scatter light differently. When larger particles are present, they scatter all colors almost equally, a process known as scattering, which makes the sky look white or dull instead of blue. This also explains why the sky appears whiter in cities with pollution but deep blue in mountains or deserts where the air is clean. The colors of the sky are a perfect example of how light and atmosphere interact, creating daily natural art that people admire around the world. Even birds and pilots use the color of the sky for navigation and weather prediction. Without scattering, the sky would look completely black, just like outer space. That is why astronauts see a dark sky even when the sun is shining. They are above the atmosphere, so no scattering happens. So next time you look at the sky, whether it is bright blue in the afternoon or glowing red at sunset, remember that this beauty is shaped by light, air, and science working together. Understanding this makes us see that nature is not only beautiful but also full of amazing secrets waiting to be explored. The sky is blue because short wavelength light blue scatters more in the atmosphere. The sky becomes red at sunset because most blue light is scattered away, letting long wavelengths red-orange reach our eyes. Simple science, yet incredibly beautiful. If you enjoyed this explanation and love learning simple science about the world around us, please like, share, comment, and subscribe. Your support motivates us to create more amazing educational content. Stay curious, stay inspired, and keep looking up at the sky. Thank you for watching.